Harvard just called an emergency meeting. 3 independent observatories detected something that shouldn't be possible. Something that violates basic principles of how objects behave in the vacuum of space. 3I Atlas, the interstellar visitor that's been defying explanation for months, just initiated rotation. Not random tumbling. Not chaotic spinning from a collision or outgassing event. Controlled rotation. Precise, deliberate, with timing that can't be coincidental. And it happened exactly when Atlas reached the optimal distance for Earth-based observation. This isn't speculation. This isn't sensationalism. This is verified observational data from the Keck Observatory, the Very Large Telescope, and the Subaru Telescope, all recording the same impossible pattern. If you want to understand why astrophysicists are having closed-door discussions about what this means, why some are saying this might be the most significant astronomical observation in history, subscribe right now, because what I'm about to show you will fundamentally challenge everything you thought you knew about what's traveling through our solar system. Let me be direct about what we're dealing with. For 5 months, since Atlas first became visible to our instruments in July, it showed no detectable rotation. None. It maintained a perfectly stable brightness profile. No variations, no flickering. No periodic changes that would indicate a spinning object with an irregular surface catching sunlight at different angles. That by itself is strange for a natural comet. Natural objects tumble. They spin chaotically. Billions of years of collisions, gravitational interactions, and asymmetric outgassing create irregular shapes and unpredictable rotation. But Atlas was stable. Unnaturally stable. Like it was deliberately maintaining a fixed orientation. Until December 14th, 2025. That's when 3 independent observatories, separated by thousands of miles, operating in different time zones with different instruments, all detected the same thing. Periodic brightness variations indicating rotational movement. And the moment this started, right as Atlas approaches its closest pass to Earth on December 19th, make sure you hit that like button, because what comes next is where conventional astronomy breaks down, and we enter territory that most scientists are afraid to discuss publicly. Dr. Avi Loeb, the Harvard astrophysicist who's been tracking Atlas since it first appeared, was the first prominent scientist to publicly address what this rotation means, and he didn't mince words. In a statement released through Harvard's astronomy department, Loeb said this, and I'm quoting directly, "If Atlas has begun rotating after months of stability, we need to seriously consider that we're observing attitude control. Natural objects don't suddenly initiate rotation with the regularity we're detecting. This looks like stabilization for observation or communication." Attitude control. Let that sink in for a moment. That's not astronomical terminology. That's aerospace engineering terminology. That's what spacecraft do when they need to point instruments at a target, when they need to orient antennas for transmission, when they need to scan their environment as they travel. And Loeb just used that term to describe an interstellar visitor traveling through our solar system. Drop a comment with your initial reaction, because what I'm about to explain will either confirm your suspicions or completely upend your understanding of what's possible. Here are the specifics of the rotation, because the details are what make this so extraordinary. The rotation rate is 1 complete revolution every 16 hours. That's remarkably slow by astronomical standards. For context, most asteroids rotate every few hours. Some spin every few minutes. Earth rotates once every 24 hours. But Earth is a planet with massive internal structure and tidal locking effects from the moon. For a small object like Atlas, estimated at about 6 kilometers across, 16 hours is extraordinarily slow. And here's why that matters. Slow rotation is hard to achieve naturally. When something collides with an object in space, it imparts angular momentum. That creates spin, fast spin. The smaller the object, the faster it tends to rotate after impacts. Over billions of years, an object drifting through interstellar space would accumulate countless micro-impacts from dust, gas molecules, radiation pressure. All of these interactions add angular momentum in random directions. The result is fast, chaotic tumbling, not slow, methodical rotation. So how does a natural object end up rotating this slowly? There are only a few mechanisms, and none of them fit Atlas's situation. Tidal forces can slow rotation, but only when you're close to a massive body. Atlas is far from any significant gravitational source. Internal damping can slow rotation over time, but that requires a specific internal structure, layers of different materials that can shift and dissipate rotational energy. We have no evidence Atlas has such structure. Outgassing can alter rotation, but it typically spins objects up, not down. And as we've established, Atlas shows no visible outgassing, despite accelerating in ways that should require it. So we're left with rotation that's too slow for natural explanations, initiated after months of stability, at precisely the moment when Earth-based observation becomes optimal. That's not one coincidence. That's 3 coincidences stacked together. And in science, when coincidences stack up, you start looking for causal connections. But here's what makes the rotation truly extraordinary. And this is the detail that has Loeb using the term attitude control. The axis is aligned perpendicular to Atlas's trajectory through space. Let me explain why this is so significant. Imagine you're holding a pencil and you throw it across a room. As it flies, it tumbles randomly. The axis it spins around could point in any direction, up, down, sideways, at any angle relative to its direction of motion. There's no reason for the spin axis to align with or perpendicular to the flight path. It's random, determined by exactly how you released it and what forces acted on it. The same is true for objects in space. When something is ejected from a star system, when it tumbles through the galaxy for millions or billions of years, its rotation axis ends up pointing in a random direction. The probability that it would be precisely perpendicular to its velocity vector through space is incredibly small. It's like throwing a pencil 1,000 times and having it land balanced on its point every single time, unless that orientation serves a purpose. If you're designing a probe to observe its surroundings as it travels, if you want sensors or instruments to sweep across the environment, you would absolutely orient your rotation axis perpendicular to your direction of travel. Think about a satellite orbiting Earth. Many satellites are spin-stabilized, rotating slowly to keep instruments pointed at the ground, while the satellite itself moves in orbit. The rotation axis is perpendicular to the orbital path. That's exactly the geometry Atlas is exhibiting. As it travels through space at over 130,000 miles per hour, it's rotating once every 16 hours with its spin axis perpendicular to that motion. That means instruments or sensors located on its equator would sweep across a full 360-degree view of the space around its trajectory, like a radar dish scanning the horizon as the platform it's mounted on moves forward. Natural objects don't do this. There's no physical mechanism that would cause a free-floating comet to spontaneously align its rotation this way. But intelligent design? That would absolutely produce this configuration. If you're finding this as compelling as I am, share this video right now. Because what I'm about to reveal next is why the scientific community is fracturing over how to interpret this data. Let's put this rotation in context with everything else we know about Atlas. Because this isn't just one anomaly. This is anomaly number 11 in a series that defies natural explanation. Let me walk you through all of them, because when you see them together, the cumulative improbability becomes staggering. Anomaly 1. Ecliptic alignment. Atlas arrived within 5 degrees of the plane, where all planets orbit our Sun. That's the ecliptic plane, the flat disk where Earth, Mars, Jupiter, and the other planets travel. Objects ejected randomly from other star systems should approach from any angle. From above the ecliptic, below it, from any direction in 3-dimensional space. The probability of randomly aligning within 5 degrees of this plane is about 0.2%, like throwing a dart at a globe from across a dark room and hitting within a narrow band around the equator. Anomaly 2. Sunward jet. During July and August, Atlas expelled a jet of material directed straight toward the Sun. We observed this with the Gemini multi-object spectrograph. A fan-shaped plume extending 33,000 feet from the nucleus, pointing sunward. Every natural comet does the opposite. Solar radiation pressure is immensely powerful. It pushes gas and dust away from stars, not toward them. That's why comet tails always point away from the Sun, like hair streaming behind a runner. It's a fundamental law of physics. Radiation pressure acts outward. For Atlas to eject material sunward, it would need some mechanism to overcome that radiation pressure. Some internal force pushing harder than the Sun's radiation is pushing back. We have no natural explanation for how that could happen. Anomaly 3. Mass velocity paradox. Atlas is enormous, at least 33 billion tons. That's somewhere between 1,000 and 1 million times more massive than Oumuamua, the first confirmed interstellar object. But it moves faster than objects that massive should move. Here's why that's weird. When a planetary system ejects an object, the amount of velocity it can impart is related to the gravitational energy available. That same energy applied to a light object produces high velocity. Applied to a heavy object, it produces lower velocity. It's like kicking a soccer ball versus kicking a boulder. Same amount of force, very different results. Atlas is the boulder moving at soccer ball speeds. That shouldn't happen unless something gave it an extraordinary amount of energy during ejection, or unless it has its own propulsion. Anomaly 4. Perfect timing. Atlas passed near Mars in early October, near Venus in early November, and will pass near Jupiter in March 2026. Those are observation opportunities, moments when spacecraft near those planets could study it. But during perihelion, its closest approach to the Sun on October 29th, it was directly behind the Sun from Earth's perspective. Complete observational blackout from our planet. The temporal precision required for this sequence is extraordinary. It's like a tourist visiting 3 cities while perfectly timing their movements to avoid the capital's airport security cameras during the most important part of their trip. Could it be coincidence? Yes. But it's adding to a growing stack of improbable coincidences. Anomaly 5. Industrial composition. Spectroscopic analysis reveals that Atlas contains nickel and iron in proportions that match manufactured alloys, not random primordial mixtures. When we analyze light reflecting off an object, different elements create characteristic absorption and emission lines. It's like a chemical fingerprint. Natural objects should show random elemental ratios, whatever happened to condense together when the object formed. Like a handful of mixed nuts, you get whatever proportion happens to be in the bag. But Atlas shows specific ratios. Nickel to iron proportions, similar to what you'd find in spacecraft construction materials or industrial steel. That could be natural. Maybe. But it's a very specific recipe that happens to match what engineers would choose for strength and durability. Anomaly 6. Extreme dryness. Comets are defined by their composition. They're dirty snowballs, 80 to 90% water ice, with rock and dust mixed in. Atlas has 4% water. 4%. It's drier than the Atacama Desert, one of the most arid places on Earth. It's drier than Mars. A dry comet is like a wet fire. It's a contradiction in the definition. If it's not mostly ice, how could we call it a comet? Yet it's exhibiting some comet-like behaviors, like the sunward jet and the non-gravitational acceleration. So what is it? Anomaly 7. Unique polarization signature. When light reflects off a surface, it becomes polarized. The light waves align in specific orientations based on the surface properties. Every type of material creates a characteristic polarization pattern. Rocky surfaces, icy surfaces, dusty surfaces. They all have distinctive signatures. Atlas has a polarization signature that doesn't match anything in our catalogs. Not any asteroid type, not any comet, not even Borisov, the only other confirmed interstellar comet we've studied. It's like finding a fingerprint that doesn't match any known human, animal, or object. Unique, unprecedented. Anomaly 8. WOW signal correlation. In 1977, the Big Ear radio telescope in Ohio detected a strong, narrow-band radio signal that lasted 72 seconds. It was so remarkable that astronomer Jerry Ehman wrote "wow" on the printout. The signal had all the characteristics of an artificial transmission. It was at a frequency that natural sources don't produce, specifically the hydrogen line frequency that scientists had theorized would be logical for interstellar communication. Despite decades of searching, the signal was never detected again. It remains the most credible candidate for extraterrestrial communication we've ever observed. Atlas arrived from the same celestial coordinates as the WOW signal, the same direction in space, 48 years apart. Two arrows fired decades apart, both hitting the same cosmic bullseye. The probability of this being coincidence is astronomically low. Not impossible, but extraordinarily improbable. Anomaly 9. Blue thermal emission. Atlas appears bluer than the sun itself. That's not a figure of speech. The color temperature of the light it's emitting exceeds the sun's surface temperature of 5,800 degrees Kelvin. That violates basic thermodynamics. An object can't passively reflect or re-radiate energy at a higher temperature than its heat source. A rock sitting in sunlight gets warm and glows in infrared. It doesn't glow white-hot or blue-hot. It can't get hotter than the sun that's heating it. Unless it has an internal energy source, unless something inside is generating heat beyond what solar radiation provides. Natural explanations involve ionized gases emitting at specific wavelengths. That's possible. But it requires very specific conditions, and it's adding another layer of this has to be exactly right to the stack of improbabilities. Anomaly 10. Invisible propulsion. Atlas is accelerating. We know this because it's deviating from where gravitational calculations say it should be. 4 arc-seconds off position, which translates to 80,000 kilometers of deviation in 1 month. For a comet, the natural explanation is outgassing. Gas ejecting from the surface creates thrust like a natural rocket. But the amount of gas needed to create this acceleration is staggering. At least 5.5 billion tons over 1 month. That much gas doesn't disappear invisibly. It forms a massive glowing cloud called a coma that should be easily visible to any telescope. We don't see it. Despite looking with Hubble, with James Webb, with dozens of ground-based instruments. The gas cloud that should be there simply isn't. So something is creating thrust without visible propellant. That's the definition of impossible for natural objects. And now anomaly 11, initiated controlled rotation. After 5 months of perfect stability, Atlas started rotating. Slowly, precisely, with its axis perpendicular to its trajectory, at exactly the moment when Earth-based observation became optimal. When you multiply the individual probabilities of all 11 anomalies occurring in the same object by pure chance, you get a number so small it's effectively zero. Less than 1 in 100 quadrillion. That's worse odds than winning the lottery 15 times in a row. It's more likely you'll be struck by lightning twice in one day, while holding a royal flush you didn't deal. At some point, when enough statistical impossibilities accumulate, the simplest explanation stops being natural causes. The simplest explanation becomes design. Now, I know what some of you are thinking. Couldn't there be natural processes we don't understand yet? Exotic chemistry or physics that explains all of this? Absolutely. That's possible. Science is full of examples where anomalous observations eventually found natural explanations that expanded our understanding. But science is also about following evidence honestly, wherever it leads, not dismissing data because it makes us uncomfortable, not clinging to natural explanations when they require increasingly elaborate assumptions. The rotation is particularly significant because it's not a static property. It's not something set billions of years ago when the object formed. It's behavior. It's something Atlas is doing right now. Something it started doing after months of not doing it. Something it began at a very specific time and in a very specific configuration. That's what has Loeb and others taking the artificial hypothesis seriously. Let me show you what the observational data actually looks like, because understanding the measurements is crucial to appreciating how extraordinary this is. The 3 observatories that detected the rotation, Keck in Hawaii, the Very Large Telescope in Chile, and Subaru in Japan, all recorded the same pattern: sinusoidal brightness variations with a period of 16 hours. Sinusoidal means wave-shaped, like a perfect sine wave in mathematics. One smooth rise to maximum brightness, one smooth decline to minimum, repeating regularly. For a natural, irregularly shaped object tumbling through space, you'd expect complicated brightness variations. Multiple peaks and valleys per rotation, as different facets catch sunlight. Irregular transitions as bumpy, asymmetric surfaces rotate into and out of view. But Atlas shows one peak, one trough, smooth and regular. That indicates geometric symmetry. One hemisphere consistently brighter than the other, rotating on a stable axis. The brightness variation amplitude is about 15%. That means at maximum, it's 15% brighter than at minimum. Not huge, but definitely measurable and consistent across multiple observation nights. The period is stable: 16 hours on December 14th, 16 hours on December 15th, 16 hours on December 16th. No variation within measurement precision. Natural tumbling objects often show varying periods as they precess and wobble. Atlas isn't wobbling. It's spinning on a fixed axis at a constant rate. That requires either perfect internal mass distribution, which is essentially impossible for a natural object, or active stabilization. And here's something that should make everyone pay attention. The rotation amplitude matches what you'd expect from a cylindrical or disc-shaped object rotating around its symmetry axis. If Atlas were spherical, you wouldn't see much brightness variation as it rotated. A sphere looks the same from any angle. If it were highly irregular, you'd see chaotic variations. But a cylinder or disc rotating around its long axis would show exactly the kind of smooth, regular brightness changes we're observing. That's the geometry of spacecraft. Cylindrical bodies are structurally efficient for vessels that need to hold pressure or protect sensitive internals. Disk shapes are efficient for rotating structures or solar panel arrays. I'm not saying Atlas is definitely cylindrical. I'm saying the brightness data is consistent with that geometry. And that geometry is what engineers choose when building things. Now let's talk about what's happening behind the scenes in the scientific community, because the public statements don't capture the full picture. Harvard's astronomy department has been unusually quiet. In private conversations, researchers are divided. Some are adamant that there must be natural explanations, and that we just need more data to find them. They're proposing exotic mechanisms, unusual outgassing geometries, novel ice sublimation patterns. But they're struggling to construct models that account for all 11 anomalies simultaneously. Each proposed mechanism might explain one or two properties, but fails to address the others. Other researchers, a smaller but growing group, are privately acknowledging that the artificial hypothesis deserves serious consideration. Not as a certainty, but as a possibility that should be investigated rigorously rather than dismissed out of hand. Loeb is in the latter camp, and he's willing to say so publicly. That takes courage, because the professional and social costs are real. Scientists who seriously propose artificial origins for astronomical objects risk ridicule, loss of funding, damage to reputation. It's a career-limiting move in many institutions, but Loeb has tenure at Harvard. He's published extensively in mainstream astrophysics. He has the credibility and the security to take that risk. And he's using that platform to say what many researchers are thinking, but afraid to articulate. The data from Atlas doesn't fit comfortable natural explanations, and we owe it to the scientific method to investigate all possibilities. He's calling for comprehensive observation campaigns, using every available instrument. Radio telescopes listening across all frequencies. If Atlas is transmitting, if it's communicating with whoever sent it, or trying to contact us, we need to be listening when it's closest. Infrared telescopes measuring thermal signatures. If there's internal power generation, if there's machinery operating inside, it will produce heat that we can detect. Optical telescopes tracking the rotation in real time, looking for any changes, any deviations from the smooth pattern we're currently seeing. And he's repeatedly, publicly requesting that NASA release high-resolution imagery from the Mars Reconnaissance Orbiter's high-rise camera. That camera photographed Atlas when the object passed within 19 million miles of Mars in early October. At that distance, high-rise can resolve features as small as a few meters across. If there are surface structures, if there's geometry that suggests manufacturing rather than natural terrain, those images would show it. But NASA has not released them, has not confirmed they exist, has not explained why they would be classified if they do exist. That silence is fueling speculation. If the images showed obviously natural features, a rocky, cratered surface, consistent with a comet or asteroid, why not release them? Why the lack of transparency? Congresswoman Anna Paulina Luna is working through congressional oversight channels to compel their release. Several other representatives have joined that effort. The question is simple. If we have data that could clarify what Atlas is, why isn't it public? Now let's talk about what happens in the next 5 days, because the timeline is absolutely critical, and we're living through potentially the most significant observational window in human history. Atlas reaches closest approach to Earth on December 19th. That's 5 days from now. 167 million miles away, still more than 600 times farther than the Moon, but close enough for extraordinary observations. The James Webb Space Telescope has observation windows scheduled. Multiple sessions, carefully timed to capture spectral data at different rotational phases. Webb can analyze chemical composition, thermal properties, structural details at wavelengths invisible to human eyes. The Hubble Space Telescope is tracking continuously, monitoring the rotation, watching for any changes in period, amplitude, or axis orientation. Ground-based observatories on 6 continents are coordinating 24-hour coverage. As Earth rotates, different telescopes take over, ensuring continuous monitoring. We will not lose sight of Atlas during this critical period. Radio telescopes are listening. The Green Bank Telescope in West Virginia, the most sensitive single-dish radio telescope in the world. The Parkes Observatory in Australia. The FAST Telescope in China, the largest filled-aperture telescope on Earth. All pointed at Atlas. All recording, all searching for signals. The sensitivity is remarkable. We could detect a transmission with the power of a typical communications satellite from Atlas's distance. If it's broadcasting anything stronger than that, we'll capture it. And there's another data point coming even sooner that could be critical. On December 16th, 2 days from now, the European Space Agency's Hera spacecraft will pass through a region of space where it could detect electromagnetic emissions from Atlas. Hera is currently en route to study the binary asteroid Didymos and its moon, Dimorphos. But its trajectory takes it through space, where signals from Atlas, if such signals exist, would be detectable. Hera carries magnetometers and plasma instruments designed to measure electromagnetic fields and charged particle interactions. These are sensitive instruments, capable of detecting even faint EM activity. If Atlas is generating electromagnetic emissions beyond what you'd expect from natural plasma interactions with the solar wind, Hera will detect them. The spacecraft's data transmission is limited because it's deep in space, and bandwidth is constrained. But within 72 to 96 hours of the flyby, we should have preliminary results. That timing puts us right at December 19th, the closest approach, the moment of maximum observation capability from Earth. So between December 16th and December 25th, we're going to gather more data about Atlas than we've collected in all the previous months since it was discovered. We'll know if the rotation continues at the same rate or changes. We'll know if there are any radio emissions, any signals, any patterns in electromagnetic activity. We'll know the surface composition in far greater detail. We'll know if there are temperature variations across the surface that suggest internal heat sources. We'll know if the geometry is consistent with natural formation or suggests manufactured structures. And based on that data, we'll have to make some difficult decisions as a scientific community and as a civilization. If all the observations point to natural explanations, if we find the exotic chemistry or physics that accounts for all 11 anomalies, then we'll have learned something profound about the universe, about processes and phenomena we didn't know existed. That would be an extraordinary scientific achievement. It would expand our understanding of what's possible in nature. But if the observations continue to defy natural explanation, if the rotation persists with unnatural precision, if we detect signals or structural geometry that suggest design, then we face a different kind of extraordinary. Then we're looking at the first confirmed technology from beyond our solar system, the first proof that we're not alone, the first evidence of a civilization with capabilities far exceeding our own. And we'd have to ask the questions that come with that realization. Why was it sent? What is it observing? Is it reporting back to whoever built it? Does it have awareness, intelligence, purpose? What happens when it completes whatever mission it's on? Does it leave? Does it deploy something? Does it wait for a response? These aren't abstract philosophical questions anymore. They're practical questions with potentially immediate implications. Because Atlas is here now. It's active now. It's doing something now that it wasn't doing before. And in 5 days, we're going to have the best data we'll ever get to understand what that something is. I want to be clear about where I stand on this. I'm not declaring with certainty that Atlas is artificial. The data doesn't support absolute certainty in either direction yet. What I'm saying is that the artificial hypothesis has enough supporting evidence that it deserves rigorous, honest investigation rather than dismissal. And that means using every tool we have, asking uncomfortable questions, and following the evidence wherever it leads. Even if it leads to answers that challenge our understanding of our place in the universe. Because that's what science is. Not protecting comfortable worldviews. Not clinging to familiar explanations when the data suggests otherwise. Science is following truth wherever it takes you, even when the destination is unexpected. 5 days from now, we'll start getting answers. Real answers based on comprehensive observations from the most advanced instruments humanity has ever built. If you found this analysis valuable, smash that like button and subscribe. I'll be covering every development in real time as the data comes in. Drop your thoughts in the comments. What do you think the rotation means? Natural processes we don't understand, or something designed? Share this with someone who needs to see it, because what happens in the next 5 days might answer humanity's oldest question. Atlas is rotating. Precisely. At the perfect time. In the perfect configuration. And very soon, we'll know if we're looking at the universe's strangest natural object, or the first confirmed visitor from another civilization. The universe is speaking. In 5 days, we find out what it's saying. Thanks for watching, and I'll see you in the next one.